In this video, I want to look what a function is. For a function, I start by inputting an element, and we say these elements are from the domain. So these are the things we put into the function. We then apply some kind of rule, which is given to us by the function. And then once we apply that rule, we output an element in what is known as the range. So let's look at some different ways that functions can be represented. One way we might see a function represented is through what's called an arrow diagram. An arrow diagram has this oval on one side with numbers from the domain, oval on the right-hand side with elements from the range, and we draw arrows with things that correspond. So let's look at another arrow diagram. Here I have another arrow diagram, in particular for the absolute value function. We have numbers in our domain, numbers in our range, and once again we have arrows showing where these elements go. And we can see that there are multiple things that go to -1, or go to +1. -1 goes to 1, and 1 goes to 1. And that's fine in a function. It is fine for multiple inputs to go to the same output. Here's another one. Here we see an issue of this 1 right here on the range. There's no arrow for that one. So everything in the domain has an arrow, and everything else in the range does, but not this one. However, that's perfectly fine. We don't need every element in the range to have an arrow pointing to it, so this is an actual function. Here, this time we have an extra element in the domain, something that doesn't go to anything in the range. And this is a problem. This is not a function. I should be able to input anything from the domain and get some kind of output in the range. So the fact that 0 goes to nothing tells me this is not a function. Here's another example where we might have an issue. In particular, this 1 goes to two different things. It goes to -1 and it goes to 1. And this is also an issue. In order to have a proper function, if I give you an input, you should be able to tell me exactly what the output is, not have multiple options. And while these arrow diagrams are nice, they can give us a picture of what's going on. If we have an infinite amount of numbers to put in the domain, they're probably not practical. And this is where equations come in. Let's consider an equation like this, 3x plus 2y equal to 6. In this case, x is our input and y is the output. And so in order to be a function, I need to be able to write this, when I'm done, as y equal to something. And I need to figure out what that something is. In this case, I could subtract 3x from both sides. I get 2y equal to 6 minus 3x. Dividing through by 2 gives me y equal to 3 minus 3 over 2x. And so this would be a function since now I was able to write it as y equal to a single thing. Let's consider something like this. Once again, I'm going to try to solve for y. I can subtract x squared from both sides. I get y squared equal to 4 minus x squared. And when we take the square root, we have to take plus or minus the square root of both sides. And this is not a function. This is the same reason my second arrow diagram was not a function. If I give you a number like 0 for x, there are two possible outputs. We need to be able to get a single output for our input, and in this case we have 2 because of this plus and minus. So this would be not a function.